In any modern railway operation, how you manage incidents with your rolling stock is absolutely critical. It has a direct line to safety, to operational availability, and of course, to financial performance. So today, we're going to dive into the shift from those traditional response methods to a much more integrated digital solution.
Here's how we'll break it down. We'll start with the landscape of incident management itself, then explore why it's so complex. We'll analyze the very real consequences of getting it wrong, introduce a digital solution, look at the quantifiable benefits, and finally, cast an eye toward the future of rail safety.
All right, let's set the stage. Responding to rolling stock damage is never a simple, straight-line process. It's a high-stakes, multi-layered challenge where every single second counts.
You have to remember, any incident, it doesn't matter if it's minor vandalism or a major collision, it immediately triggers this complex web of interactions. You've got different commercial entities, specific operational procedures, and critical assets all in the mix. And every single piece demands precise management.
So let's get into the specifics. What are the operational hurdles that make this response so complicated? It really comes down to the division of responsibilities and the limitations of older, more traditional methods.
The railway ecosystem really boils down to three key players. First, you have the asset owners, often called ROSCOs, and their job is to protect the asset and sign off on major repairs. Second are the train operating companies, the TOCs, who handle the day-to-day care and immediate reporting. And finally, you have the maintainers, who perform the expert assessment and the actual repairs. Now, this division of labor is necessary, but it also creates a natural point of friction. It can lead to some significant coordination challenges, especially when your communication is manual or happening across disconnected systems.
This is where traditional methods, whether they're paper-based or just fragmented digital files, really start to show their cracks. They introduce critical points of failure. Decisions get delayed because of information lag. Crucial details that are needed for investigations or insurance claims often get missed in those chaotic first few hours. And maybe the most critical part, trying to establish a complete, indisputable audit trail from the moment of the incident to its final resolution is next to impossible. To really grasp why getting this right is so important, we're going to look at the real, quantifiable consequences of structural damage through a couple of engineering case studies.
Our first case here involves an electrical fire on an electric multiple unit, or EMU. The fire itself was actually quite brief. It lasted less than 10 minutes, but the thermal impact on the vehicle's aluminum car body was so severe that it demanded a full-scale engineering assessment. And the precision of that assessment is what's so revealing. Hardness testing showed a 57% reduction in the material's structural strength right in those heat-affected zones. Let that sink in. A loss of over half its strength made that vehicle fundamentally unsafe for service. It's a perfect example of a hidden, critical consequence that goes way beyond what you can see with the naked eye. This risk assessment just quantifies the stakes perfectly. After the fire, the vehicle had a critical risk score of 24, which indicates a potential for multiple fatalities. After a properly documented repair, which involved replacing those compromised sections, that score dropped all the way to 6, back within an acceptable level. This really drives home how essential a thorough assessment and a certified repair are to guaranteeing public safety.
All right, our second case study looks at a high-speed collision. An engineering team was brought in to conduct a structural assessment, really to validate the vehicle's crashworthiness and to map out a repair strategy.
The analysis found that the front structure withstood a peak force of over 2,000 kilonewtons. Now, while that was still 31% below its ultimate design limit, the sheer magnitude of that force meant a forensic inspection of the vehicle's energy absorption zones and bulkhead was absolutely necessary to rule out any hidden damage.
But here's the really critical part. Those forces didn't just stay at the front. They propagated through the entire train. Even the trailing car, the one furthest from the impact, experienced a peak acceleration of 3.23 g. Since all the onboard equipment is designed to a 5G limit, this confirmed that a 35% safety margin was maintained. But it's a powerful reminder that you have to assess the entire train, not just the visible point of impact. So, we've laid out the challenges and the very high stakes. Now we can turn to the solution. A centralized digital platform that's designed to manage incident response from the very beginning to the very end. A digital workflow immediately brings structure to the chaos of those first few hours. It guides teams to assess damage systematically.
It lets them capture time-stamped photo evidence. It enables real-time collaboration between the operator, the owner, and the maintainer. And it generates instant reports for investigators and insurers.
And the effectiveness of the solution really lies in its core features. You have damage heat maps that offer an intuitive visual summary right away. Real-time evidence capture guarantees the integrity of your data. The structured data collection is designed specifically to align with the requirements of regulatory bodies. And finally, that complete end-to-end audit trail creates a single source of truth for every stakeholder involved. Okay, now let's see how this digital approach translates into tangible, measurable outcomes. Because adopting a platform like this yields quantifiable improvements in both safety and operational efficiency. This number brings us right back to our first case study. That 75% reduction in the operational risk score wasn't just the result of a physical repair. It was the result of a documented, auditable, and data-driven process that certified the vehicle's return to a safe state. The financial stakes are just as high. The total documented cost for that fire damage incident was over £500,000. A digital platform gives you the granular cost tracking you need for accurate apportionment between stakeholders and for effectively managing insurance recovery. So, to sum it up, the operational gains are crystal clear. Incidents get cleared faster, which reduces service disruption. Investigators get comprehensive documentation from the moment an incident occurs. Collaboration is streamlined, which removes bottlenecks, and cost control is vastly improved through transparent tracking and reporting. Finally, let's wrap this up by looking at this technology not just as a better reporting tool, but as a fundamental shift in the entire philosophy of asset management and safety. You see, the real power of this digital transformation is the shift from a reactive safety model to a proactive one. Every piece of structured data you collect, from the type of damage to its precise location, stops being just a record of failure. Instead, it becomes a valuable asset you can use for trend analysis, helping you identify systemic risks and inform predictive maintenance strategies. And this brings us to our final thought. When you capture high-quality, structured data from every single event, you create this expanding knowledge base that can inform everything from vehicle design to operational protocols. The focus shifts from simply managing an incident to actually learning from it. And that leaves us with a really critical question. What if every single incident, no matter how small, could contribute to making the entire network systemically safer?